as I mentioned, if you have further questions, you can actually go to the detailed definitions and explanations, but we need you to make a decision and meet with your team and talk in the student lounge is the best way for communication and make your team as soon as possible. So there is a deadline for team to pick the case and introduce one person who is leading this, and then we will create a group in web course for you, and then you will and then we will introduce you to the industry as well. Okay, makes sense? Clear? Okay. So without further ado, I move to the first presentation, Mr. Chris Wogan.
Great. Can you see and hear me?
Yes. Chris, do you have any slide, or you want you just talk?
Yeah, no, just talk. I'll make it very, very brief and just kind of tee it up for the team and hopefully recruit you to Project A. So it's wonderful to be with you all. My name is Chris Vaughn. I'm the founder of Valor Analytics. We're a disaster analytics firm. My background, I was with FEMA for almost 13 years as their geospatial information officer. Got a strong relationship there with Soheil and Digital Twins. This will be my third cohort supporting this class. I'm super excited to continue this work. In fact, I was just down at UCF, about a month and a half ago, Soheil, 2 months ago. We had a NATO class focused on artificial intelligence. So we covered a bunch of different AI elements to include the use of digital twin for disaster response. So being that this is the third time going through this, the first time we went through it, we kind of did this very broad brush about how digital twins could support natural disasters or major incidents of national concern. Then we started picking it off and realizing that we needed to get a little bit more topical or focused. So the next one, we actually focused on communications. And so my background is specifically here in the United States. And in the United States, we have 8 lifelines. Communications is one of the 8. Power, transportation, it goes through all of these elements. Wrapped inside of that is this problem set called humanitarian logistics. So for this third iteration, I decided to focus in on humanitarian logistics. It's something that pops up every time you've got a massive incident. It just disrupts a lot of things like supply chains. And how do you get the right resources in at the right time to the right people? And so with that in mind, we only get so many chances to meet with each other as a cohort. So my attempt at this time, and I learn every time we do this, I'm going to actually bring in almost a panel of my colleagues and peers. So you not only get me, but you get about 3 or 4 of my favorite and closest friends. And we as a group are going to be focused on Hurricane Melissa, which affected the island of Jamaica. So it's the tyranny of distance. It's an island in the middle of the ocean, massive disruption from this massive hurricane. How do these nonprofits and volunteers get their supplies in? So you'll hear directly from folks like Samaritan's Purse, SBP, which is an offshoot of Google Crisis Response, Map Action, and I think I've got one other World Central Food Program lined up. So you're going to get a group of us actually giving you some real world experience on what we saw and heard during the Jamaica response, and as they're continuing to rebuild and recover from that tragic incident. So once again, thanks Soheil and to the UCF team for this opportunity. Happy to answer any questions that the team might have.
Thank you, Chris. Any question? So as Chris mentioned, I think every year he actually brings a group of other expertise in the topic that he has. So they will join the students and they talk to each other. They provide the information and the data. So hopefully, if you are interested on this topic, please go ahead and on the topic and reach out to us. We will make introduction. Chris, thank you so much.
Thank you all. Thank you.
Okay, the next one is Dr. Azevedo is about the human digital twin.
Hey, Sohail. Hello,
Hello.
class.
Do you want to, do you have anything to present?
I've got a couple of slides, Sohail,
Sure.
if that's okay. If I can share,
Let
please.
me see if I need to do any changes. So can you share? Or
Not yet. It says it's disabled.
okay. All parts. Every time this technology come with something new.
Oh, let's see.
So while Dr. Azevedo is bringing this up, again, one of the leads of digital twin in the University of Central Florida, Dr. Azevedo, and human digital twin is the expertise area. Please, Roger. We can see your screen, Roger, but we cannot hear you. I think he's gone. Roger, can you hear us? You're muted. Okay.
Yeah, I can hear you.
A second.
So
Let's
you
try this
share the
again.
screen, the sound goes,
Yeah, when I share the
all
screen,
the screen,
okay.
the sound comes back.
Okay, what about now? Is all good?
All good, yeah, all together.
All right. Well, thank you so much. And let's start with thank you so much for the opportunity. I think this is the second time we do this. Pleasure to be with you here tonight, or I guess virtually, class. And so this is a continuing project that we have with the College of Nursing. So I'm a faculty member in the School of Modeling, Simulation, and Training. I'm a psychologist by training. And we really are interested is in a human digital twin of the expert nurse practitioner preceptor. And I'll segment those all those words in a little bit in a slide or two. But this is continuing work and collaborations that we have at the College of Nursing in terms of thinking about accelerating the training of nurse practitioners who are in extremely high demand, especially in the next 10 years. So this goes back a little bit to some of the framework that was back in, 4 years now, that we developed a conceptual framework for this meta digital twin. So we're asking very, deep questions, if you will. And then, of course, as a psychologist is, what are we modeling? Why are we modeling it? And is it effective? How does a human digital twin interact and communicate with another? How do we measure success in modeling and simulating humans and their human digital twins? And would they live in a real world or an immersive environment? And of course, we're also very interested in the role of AI in both modeling and simulating these twins and their humans. This goes back to a framework that we developed a couple of years ago that actually led to the hiring of several of our faculty across different colleges. So nurse practitioners. So I am not a clinician. We work closely with clinicians. So in our team, if you decide to participate and work with us, you will have access to modeling and simulation faculty. You'll have access to psychologists, postdocs, grad students, and also we work closely with the Associate Dean of the College of Nursing. So we'll have a lot of access to clinical folks, specifically nurse practitioners, okay, who have advanced clinical training. Okay, in fact, in the US, they do a lot. They're very similar in terms of what a clinician does. Okay, when you think about even diagnosing and prescribing. Now, the issue is that there is a fundamental training issue. These nurse practitioners, so the clinician that you see in the lab white coat on the top with a blue hat, she is a nurse practitioner, but she's a preceptor. So a preceptor is actually, if you think about it, is an expert, right? Expert teacher. They're very expensive. They don't have that many. So we would like to do, and what we have been doing for 2 years now in collaboration, is basically modeling the clinical decision-making and the pedagogical and training processes of nurse practitioner preceptor. And so we're focusing a lot of data. We're collecting a lot of data currently in the College of Nursing to understand really and get the fundamentals of what makes them an expert, but not just an expert as a clinician, but an expert teacher and trainer, right? So that's really what the focus is on. There's plenty of evidence that, for example, there's going to be a decline in physicians. For example, the next 10 years. Meanwhile, we're seeing the reverse in terms of nurse practitioners. They're in high demands, and they actually paid very, very well. Overview, I'm sure I'm not going to go into too much of this. I want to really contextualize this, but we contextualize this in a lot of the work that on human digital twins. And those of you who are familiar with Dr. Sabri's work, there was the book that came out just last year that we had a chapter that I'll show you. So we do have some information. And so the question becomes, what are we measuring? What are we measuring? What are we modeling in this expert nurse practitioner preceptor that's going to be a human digital twin? How do we make these decisions? What are we modeling? Why are we modeling it? And for what purpose? Because part of the vision that we have is that the expert nurse practitioner preceptor can live in any kind of clinical training, whether it's in a college of nursing, for example, but it can also be in a pharmacy, et cetera, in a hospital setting. Regardless, it could be in any ubiquitous clinical setting that provide that extra support for example, a novice nurse practitioner. What we really are trying to model is, this is a clinical decision-making model, right? So this could be one of the foci for those of you who decide to maybe take this on as a project, is how do we model these processes? Everything from data gathering, interpretation, evaluation, and making a decision and a final diagnosis, okay? Many different issues, so that could be of interest, right? There's a slew of interest as to why experts are needed. So the expert nurse practitioner preceptor is extremely important because we're trying to minimize diagnostic errors, minimize the number of medical errors, enhance the patient's outcomes, etc. Okay, and I can share these slides. I'm not going to go through all of these, but there's many different ways of justifying why an expert nurse practitioner preceptor digital twin of that person would be extremely important. And so one question is, if those of you are interested, is again deciding on what features of the expert nurse practitioner would you model? Is it just purely clinical decision making, or does it have to be something else like situational awareness, cognitive load, right, etc.? We use a computational model of metacognition to basically build out, if you will, the brains of the human digital twin preceptor. So there's a lot of computational modeling that could be potentially involved, depending again on who's interested and the angle that the team is willing to look at. So we'll have a lot of models from cognition, cognitive psychology, and metacognition, metacomprehension that we can borrow from, that are contextualized and then contextualized into clinical decision making. And then we in our lab focus a lot on multimodal, multi-channel data. Of course, this is not a nurse practitioner, but this is the kind of data that we were able to collect and have collected. This is multimodal, multi-channel data. So pretend a student is engaging in clinical decision-making. He's actually in a different task, but this is the kinds of data that we collect, right? So he's verbalizing, so that would be clinical decision-making. We have access to the expert nurse practitioner's physiological data in the bar here. So in this particular scenario, there's a bar for eye tracking, right? But of course, the nurse practitioner would be wearing a portable eye tracker, just like glasses like I'm wearing. There will be video recordings for audio and gestures, et cetera, and how they interact with a patient. And now we can work with real patients or standardized patients or even virtual patients. And so a lot of the stuff that we do is basically there's a human. So think about the human here on the left-hand side as the nurse practitioner preceptor expert. They're generating a lot of data. The data is being fed into the digital twin. One question is, how often is it fed? Which type of data is fed? Is it the cognition, metacognitive data, et cetera? Affect, it could be affective response, okay? And then the question is, once we start modeling this in digital twin, then can the digital twin or should the digital twin feed back some of that information that has been synthesized and classified back to the human so the human can continue accelerating their expertise? Okay, here's an example. So in terms of work that we already have, so this picture here on the left, because I'm trying to be mindful of time also, is we have Dr. Wiedbusch, who's one of my postdocs. This is in the College of Health Professional Science. We have actually designed and developed a digital twin of Megan Wiedbusch. Okay, and so we're experimenting with AI techniques to basically do some disease and model progression, acceleration. Okay, so those techniques exist. And then, we have a lot of open-ended questions. So this is part of the team that we work with. They're now also not only College of Nursing at the University of Central Florida, but we also have colleagues at Miami University. Sample scenarios, they would be generating, the scenarios are very open. It could be a pediatric case, it could be an acute triage case, it can be chronic management, right? We know that this is a leading funding. So for scenarios, we have scenarios, we can build new scenarios. And this also basically is an extension of some of the work that we have. So back last year in Dr. Sabri and colleagues' book, we do have a chapter that kind of lays out the computational aspects of what a human digital twin for a nurse practitioner would be. And this is with colleagues in SMST, College of Nursing, and Sortec Technology across the street from UCF. And this also is a continuation of the work. So Sohail actually led one of these publications that just came out a couple of months ago, actually just before the holidays, where we continue to investigate the integration of human machine systems and digital twins. And yeah, I'd like to thank you for your attention. I will stop sharing, and I'll answer any questions that you may have.
Thank you so much. I appreciate it.
Thank you.
Roger, any question? Again, so this description is already there. The presentation is already recorded, so please go through it and make a decision. I know some of the students have some interest on the health and human dimension, but I really appreciate your time, Roger.
My pleasure. Thank you for the opportunity. So,
thank you so much.
Thank you, class. Thank you.
So next is digital twin for supply chain disruptions during extreme events. HNTB, Eric.
Are you guys able to see the screen and hear me?
Yes.
Okay, great. So I'm Eric Zucker. I'm a bridge engineer in New York with a company, HNTB. I'm going to do just a little bit about myself, a little bit about the way that I approach these challenging problems facing the supply chain and the transportation network, and then I'll go into the specifics of the data. I was sort of a regular bridge engineer up until Hurricane Ida, and that's actually me with a backpack standing on top of a failed bridge. And it was seeing this bridge washed out that I realized the deep intersection between extreme weather, the way it changes our cascading transportation networks, and the way failures actually impact tens of thousands of people, and the sort of society around us. All the New York garbage trains could not get out of New York City, and they had to do a lot of workarounds just because of the single failed culvert. That's when I realized the importance of understanding resilience and the way that these data systems work together. So as far as my background, I am a bridge engineer through and through. I have been for about 15 years at HNTB. I started off as an inspector, was able to move into the design phase, worked with lots of finite element software and analysis, actually got to see some of my construction designs come to construction, and got to take some cool pictures on top of bridges, although at this point, later in my career, I'm much more afraid of heights than I was when I was younger. That's really the conventional background that I have as a bridge engineer, whereas I also have an entirely different background, also with my same company, serving as the firm-wide bridge technology lead. So really anything having to do with data or analysis lands on my desk from around our company. And so that includes a lot of different things like gathering data about the way the structures behave with sensors. That's me up on the Kosciuszko Bridge, gathering data on the acceleration, looking at the way that resilience impacts our structures, doing data analysis, including visualization, dashboards, and some machine learning, and then looking at the way that freight, and specifically trucks, affect the transportation network and the bridges that we show. Now, I just like to give a disclaimer here whenever I give this slide, which is I don't have expertise in any of the areas bolded there, but the benefit has been for me that I've been able to interact with people and experts in these various fields. I got to fly down to the NOAA headquarters in Asheville and actually work with their climate scientists. I was able to work with risk and statisticians on a number of the projects that I've been able to work on, and actually get to meet many of the hydrologists who keep some of our states from having resilient infrastructure. And so the way that I approach the world, and again, I'm an engineer, so that's my fundamental, the way that I approach it, but this is the way that I see it, is that up until now, we've always relied on this idea that the world is generally static. And for a lot of different reasons, that is no longer the case. And so if that is no longer the case, how do we approach this new world? And I think the answer is the class that you're taking. We gather data about these systems, we understand the way that they interact, and we model them and to both understand what is going on at the current time, but also be able to run scenarios and better prepare overall systems. Probably goes without saying that, the supply chain, the freight network are the things that keep our grocery stores stocked. They're what helps our economy move and without disruption. So critically important to everything that we do. And so within that shifting landscape, I mentioned the sensors already. The Tappan Zee Bridge, which I oversee the structural monitoring system for. We've got about 430 sensors, 27 million lines of data come in every single hour. And so I've been the one who has to build the Python scripts, the data pipeline to ingest and understand that data so that during hurricanes, earthquakes, and what have you, we're able to give answers to decision makers very quickly. The extreme weather side of things I've touched on a little bit. This is a bridge washed out during Hurricane Harvey in Texas, 250,000 year return period event. Our entire transportation network is being damaged significantly by these hurricanes, like the ones I'll talk about momentarily for the project. On the freight logistics side, freight is moving at orders of magnitude more quickly than physical infrastructure or even our understanding of it can keep up. And so we have to do everything we can to collect the best available data. And then on the generative AI side, this is deeply consequential in the way that we tackle these problems, especially from a multidisciplinary perspective. And I think also the way that that engineers will act in the coming years. So zooming back in then, now you know who I am, sort of my worldview, agree or disagree, and then zooming into the project at hand. This is the work that initially an intern of mine did 2 years ago. They took a lot of the weight data from Florida, which is truck weights, and they were able to post-process it in a significant way. Suddenly, about 30 million lines worth of data were compressed and histogrammed out into a dashboard that was only a single megabyte, a relatively small file you could email. And so by being able to do that and look at these historically over time and at given locations, a sense of the network emerged rapidly because of the way we had structured, visualized, and were able to query the data. And just talk about what type of data we're looking at. It's called weigh in motion, relatively unknown outside of the transportation system. It's these plates in the roadway, and they tell you exactly how much each of the axles weigh and how far apart they are. And so it's almost like you're standing there basically with a traffic counter counting each truck that goes over. Except that you are able to look at the weight and how much they are. So you can tell which trucks are empty, which trucks are not. And so why that really matters is because we were given a huge data set from the Federal Highway Administration, which I'll talk about in a minute. And we were able to post-process that into not only data frames, but also into an easy to query structure that shows up in dashboards and can be worked through. And so this is one of the dashboards here that we show. We have 6 billion rows of data representing a decade of time over 44 of the states in a country. And so the work we would be doing is looking through this data set. It's auto-advancing, I'm not sure why. We're working through this data set, looking at the specifics of how the transportation network reacted to various storms. So this is work that I oversaw a different student, a different intern of mine did recently, Walter at Lehigh University. Is he tracked various hurricanes that went through and was able to show what the trucks counts and weights look like on certain days. And he was able to then see how these react to the hurricanes. And so by doing this and pairing these things, he's pairing it not only in the geospatial sense, but also tabularized, which means machine learning or pattern recognition are something we can look at. And so keep skipping ahead, so I'll just stop the screen share. The reason we feel this is so consequential is because freight companies try to modify their systems and their logistics leading into a hurricane, depending on where it's planning to hit. There's different areas of the state that are deeply connected, especially with the how linear the state of Florida is. And so the geospatial disparity of where the freight is affected is consequential. After the hurricane or during the hurricane, almost no trucks are out there, but how the system bounces back, especially along different corridors and different parts of the industry, is something that is worth looking into. And also the idea that once these hurricanes go through, there's significant amounts of debris for the times that there's been significant damage. For those, we usually see overweight trucks, which put strain and stress on our roads and bridges. So quantifying that is very important to understand the economics of the roadways that we maintain. And so by pairing the extreme weather data, which is very much public, the weigh in motion data, which was provided to us by Federal Highways and can certainly be utilized for this class project, we feel we can draw a lot of conclusions and also learn how to pair these things both in space and time to yield insights.
Thank you very much. Any questions?
Yeah, I have a question. It's what type of results are you looking for, and what's the modeling in the digital twin that you're looking into? Is it the transportation network, the weather, or what, or a combination of the two?
Yes, it wouldn't be modeling the weather. It'd be utilizing weather data that exists, right? Hurricane tracking over time, and then pairing that with the transportation side of things. So the predictions that would occur, and the really analysis would be on how the transportation network reacted to the hurricane. For states like Florida that have to prepare and continue to make resilient infrastructure investments, knowing how the network responds and behaves when it's under duress is really important for guiding those dollars of where they should go, and also understanding how to best restore the network after these events to get things like critical supplies to various people in the state.
Thank you.
Another question. I understand your focus is on freight, but does the data set from Federal Highway Administration also include like regular cars as well, or only captures trucks?
Yeah, so the state of Florida does collect all vehicles, and that probably is available through the DOT, although I don't have access to that. The Federal Highway Administration, this is their freight data team, so it is only trucks at this time. I think that the vehicle or passenger vehicles probably would be another equally interesting study, because we know that people are trying to get to where they need to be prior to the hurricane starting. On the freight network side of things, because there is such a demand for these goods to be where they need to be up to and right after the hurricane, that's the data set that we at least have at our fingertips at the moment.
Yes, thank you.
Okay. Any other question? All right, thank you very much, Rick. I appreciate that. And next, we go to digital twin for modeling economic impacts on urban environment.
All right. So I'll just unmute here.
And share my screen.
You can keep that one
Wait a
muted,
second.
and then you can bring your laptop with you here because they will see you here. You want to share the screen as well?
Yes.
Okay. Then they will hear you from here, and then you can share yours.
All right. Good evening, everyone. My name is Jordan Dobble. I am representing a company that's local to Orlando. It's called Symblocks.io. I started the company about 10 years ago, helping our customers in the area of military simulation and training. Companies who build things like marksmanship trainers that you see here, or aircraft simulators, vehicle simulators. I think it's pretty amazing, like the types of applications that you find, like the presentations on healthcare and logistics. And you think about where you're at now and how you can contribute to in your future careers and helping companies out. There's so many possibilities, different ways to apply modeling and simulation. One of the big problems that our customers were facing is they wanted to upgrade their trainers to have better graphics and more immersion, things like virtual reality, augmented reality, more physical dynamics going on. And so they really wanted to figure out how to upgrade their older legacy technologies towards using game engines like Unity and Unreal, to help them produce better graphics, but also start leveraging some of the same tools that game developers might be making and using. So as part of that process, our customers quickly found the same types of problems over and over again. Like, how can you reuse geospatial content, synthetic terrains that have been created to represent different areas, like airports or bases or just areas of operation? How can you reuse those in these new game engines? So that's where our company decided to focus, supporting the types of 3D formats that are widely used in our industry, and also formats that were being adopted over the last 10 years, things like 3D tiles and GeoPackage. And the other area our customers had problems with is, how do you take these game engines and get them to communicate with existing simulation applications? Because you're generally not running a big simulation on just one computer, but you got like a federation of computers all talking to each other. So here's an example of a large world visualization that we created, where you can view a base terrain for the whole Earth, and then you can add synthetic terrain on top of that. So this is a CDB terrain that we acquired from one of our customers, and we're showing that in Unity here. And then once you have your content in these game engines, you can then deploy them on multiple operating systems and devices. So to support virtual reality and augmented reality applications. We also have worked with a tool that's really taken off over the last few years, and that's called Cesium. Dr. Sabri knows about Cesium, right? If you've seen the Santa tracker, that Cesium is the technology behind that. And that's just another way to view the whole Earth, but now they also support the moon, and you can view cities on the Earth, and it's really great as like a foundation of a geospatial application. You can also bring in Google Maps type information and OpenStreetMap and view data in this. It doesn't have to be completely realistic, but like simplified views of the Earth. And you can click on buildings and get metadata and show them in different ways. And so we experimented with, well, how could we apply this with commercial use cases, such as real estate visualization, where you might want to get information about neighborhoods or specific buildings. Or in this case, if I'm interested in a home, which hospitals are around where that neighborhood is? Where are the nearest trails? Where are the flood zones, right? And if you're in a flood zone, which type of flood zone? But for this project, we're going to propose something slightly different than what our company has been working on, but hopefully using some of the same tool sets. If you think about the idea of modeling the economic impacts on urban environments, what are the types of things that you might be interested in modeling? So real estate is one option. Also tourism, if you live around Orlando, that's a huge industry. If someone wants to visit Orlando, how can you provide curated information to them so that if they're just here for 3 or 4 days, how can they get the most experience out of that time? And what data can you present to them to help them make the best decisions for them? Maybe you're a city planner and you're figuring out how can I get out-of-state businesses to move towards Central Florida. What information would they be interested in knowing about? Things like the education level of the population, different expenses that your employees might have depending on where they're living. Or maybe consider other things that might be going on in the present day. How would increased tariffs affect the economy in Central Florida? How would deportations, or what if what's happening in Minnesota is happening in Florida? How could that affect our economy? So these are just ideas I'm throwing out, and it's really, if this is something you guys are interested in, really, and up to you guys what you might be wanting to pursue. But I'm just making myself available tonight and throughout the semester if you have any questions or anything I can do to support you. So, thank you.
Any questions? So just to let you know that hospitality and tourism is one of the major industries in Florida, for sure. I just received an email from Rosen College of Hospitality. Rosen College of Hospitality is the #1 in the world, according to their website. So in the tourism hospitality aspects, and they are interested on Airbnb Digital Twin, that they are interested to know more. So potentially we can actually talk, because they actually have the colloquium and they want to know how to leverage the Airbnb Digital Twin for their different activities. So if any of you are interested on this topic, certainly this is a very good opportunity. All right. Now, the last but not least, Omije Maxwell Digital Twin for Seismic Radiological Emergency Preparedness and Response. So this is by chance that we got 3 projects relevant to the disaster. The reason we actually we have more disaster type because digital twin makes more sense when you have unexpected behavior. You have a lot of uncertainties and you have things are going on and you don't know what will be happening next. So that's the reason you see a lot of things. Maxwell is going to be joining my lab very soon as a postdoc, and he's my first PhD student back in 2012. So we have been in constant connection, and then I think this is why by chance that he comes back again to us, and he has a wealth of experience in the radio activity and contamination on the geological aspects. So he brings the case here in case anyone is interested. He will be available in person. Maxwell, can you hear me?
Yeah, I can hear you very well. Thank
Okay,
you very much for this opportunity.
no worries. So can you go to presentation mode, and then you can start your presentation.
Yeah.
I think it's bottom.
Yeah, can you see my screen?
I can see your screen, but it is not in presentation mode.
Okay, yeah.
Okay. Yeah.
Okay. Once again, thank you so much for this opportunity. The title of my project is Digital Twin for Seismic Radiological Monitoring System, Real-Time Emergency Response and Preparedness. So this project describes how digital twin system specifically to support environmental monitoring of seismic and radiological hazards. So sorry, I'm trying to shift. It's not moving.
No. Yes. Oh, it stopped.
Okay. Okay. So the mission is to see how we can develop the open group architecture framework that aligns with digital twin system to monitor and respond to compound seismic radiological emergency in real time. So we're looking at, before now, in isolation, seismic activities are being monitored and the radiological impact is being monitored. But we're trying to see how we can integrate these two using a tool called digital twin to be able to visualize the situation of this radioactive element coming as a result of seismic activities, and at the same time where the nuclear plants are situated, how safe it is, because they are aging here in the US. So we try to marry the two to be able to see how the situation on ground when these activities are being taking place every now and then. So the real-time monitoring system for earthquake and radiation events are going to be looked at. Talking of the scope, then we're going to integrate the seismic data from the sensors and radiological data from the detectors that we're going to apply as the data for the digital twin. At the same time, the geological features where those activities are taking place, which are termed as environmental data. So we're going to get this. Then at the same time, we're going to look at how we're going to work together with the multi-agency platforms like International Atomic Energy Agency, Nuclear Regulatory Commission, then at the same time, United States Environmental Protection Agency. We're going to see how these agencies are going to come together to be able to see how all these things are going to be coordinated and situate the nuclear plant where it will be safer and where people exposure will be at a minimal point. Then the risk model will be predicted using Monte Carlo. So that area, you use that risk model to be able to know the exposure level to human. Then the project timeline is 10 weeks. Then the approach is this agile methodology using these tools, these softwares to be able to get all this information step by step and match them together to be able to achieve the goal. Then there will be stakeholder interviews at the same time, deliverable working prototype. When we get the prototype at the end of the day, we should be able to know where there are gaps, where the framework is lacking something for us to be able to beef it up. Then all these things will be documented. Then the key innovation here is, unlike before, systems that treat seismic and radiological hazards, or the two are in isolation. Our digital twin will create a unified real-time view that enable proactive decisions making, faster response time, and coordinated multi-agency action to disseminate information, what to do, how to do at the appropriate time. That's where we now have during compound disasters. Then the TOGAF architecture layer will cover the business aspect, the data aspect, the application aspect, and the technological aspect. Then, because of this problem where before now we have fragmented system where seismic and radiological data are treated in isolation, that creates blind spots. And that makes the whole thing, you discover that before action will be taken, something disastrous would have happened. So here at this point, we use real-time, no real-time integration. There's no unified tool exists for compound seismic radiological risk assessment. You handle this before you bring them together to be able to achieve a formidable data interpretation. Something disastrous would have happened. It will delay decision. At the same time, reactive protocols will take place instead of proactive. Then the result will increase radiological exposure risk. If, as it was before in isolation, you see exposure risk will be high, inefficient resource development, and potential loss of lives. So, but digital twin came to be. This is now the solution. An AI-powered digital twin that integrates seismic monitoring, radiological tracking, and emergency response coordination in real time will now be adopted. And you see data integration. Now we're going to extract from USGS seismic feeds, radiation sensors. We're going to get the information there. Then weather data, we're going to get from NOAA population data sets at the same time. Then when this is integrated, then you will now see the live dashboard where the interactive maps will now show. Apparently, you see the situation on ground, the real-time metrics, where the exposure is high, where it is low, where evacuation is supposed to take place. You see plume dispersion, plume visualization. You see the dispersive nature of the whole thing, where the hotspots are and what the measures to be taken. Then you see the hospital situation at the same time. What will happen when the situation is high, the situation in the hospital, the status in the hospital. Then you see the smart alert. When the threshold of the exposure is high, the radiation that is emanating is high, you will now look at the threshold. Now, at this point, once it gets to this point, people should now be asked not to keep away from this point, to do this, to do that. Then the multilingual communities where the messages will be disseminated on time, people will not be raised where you see heavy disaster within a short period of time because information will have been provided in different languages. Then multi-agency, just as I said before, International Atomic Energy Agency, Nuclear Regulatory Commission, emergency management, all of them will come together, work together, create a framework, a platform where information will be shared. Then application program interface will be created as well, where apps are going to be created for easy dissemination of information regarding this. Then the key system capabilities, we talk of real-time seismic monitoring, live earthquake detection with magnitude, epicenter, depth and peak ground acceleration data will now be gathered. The Rodrigo dispersion model will be created using Gaussian plume model, integrating it with HYS, SPLI, or RASCA. This Gaussian model has limitation. Then integrating it with this HYS, PLI will now visualize the real information of what happens along the streets, along the buildings, or within the buildings, within certain hours. All this information will be explored, and the integrated result will be shared. Then multi-agency coordination, unified command structure, integrated FEMA, and Nuclear Regulatory Agency, USGS, NOAA, all the local respondents with shared situational awareness will be created immediately. Then evacuation zone management, all this point, this epicenter, these hotspots, all these things will now be managed appropriately within a stipulated time. Then we have two simulation scenarios here. One is the one that happened in Cascadia's subduction zone. The earthquake magnitude then was about 8.2, the depth about 20 kilometers. The location is Cascadia. Then the facility is Columbia Generating Station. The impact was huge. About 3,500 people were affected. There is potential containment breach because the isotopes were seen emanating from were detected emanating from such activities, like cesium-137, very dangerous radioactive element, then iodine-131, strontium-90, and cobalt-60. All these things were detected with the activities that happened then. The intensity was about 9, violent shaking the environment. Then the second scenario happened in Los Angeles, urban event, 6.9 magnitude earthquake. Then the facility then was a medical radioisotope plant where isotopes like 99, iodine-131, and fluorine-18 were discovered. So the intensity was about severe shaking. So both scenarios test real-time detection, contamination modeling, and multi-agency response coordination. So then look at the TOGAF alignment system architecture. We're going to look at the business aspect, which has to do with emergency manager, first responders, government agencies, public health officials, utility companies, and general public. Then application architecture will handle real-time monitoring dashboard, predictive model engine, alert generation system, API gateway, event-driven microservices, multi-agency coordination platform. Then the data architecture will handle real-time sensor feeds, geospatial database, that's GIS, Historia event data, FAIR principle compliance, open geospatial consortium standards, EDX, that's emergency data exchange. The technology aspect has to do with Python, Flask backend, Kafka streaming, PostgreSQL, PostGIS database, Grafana, Plotly visualization, Dockers, Kubernetes deployment, cloud platform. All these are technological architecture that will be deployed. Then data integration of real and simulated sources. These are the part on the left is where we source the data from USGIS, NRC, NOAA, US Census Bureau, OpenStreetMap. Then the simulated data will be earthquake scenarios, plume dispersion model, population movement, infrastructure damage, and weather condition. Then the real-time monitoring dashboard, you can see the outcome of it, where you see interactive maps, real-time plume visualization, evacuation zones, then facility locations, real-time sensor reading, and infrastructure status. Then you can see the live metrics where response time tracking will be apparently seen, evacuation progress in percentage, hospital bed availability, system health indicators and risk assessment sensors. Then alert system where threshold will be alerted, multilingual notification will be created, agency coordination, the same as web hub integration, EPAS integration, IPAWS. All these things are going to be made available. These are the workflow. Project setup and planning will be the first 3 weeks, 1 to 3 weeks, 1 to the third week. Then the data collection and integration will be week 5 to 6. Then week 6 to 7 will be system development. Week 8 to 9 will be testing and simulation. Week 10 will be final review and delivery. Then these are the expected results, where you see technical deliverable results, then documentation result, then learning outcome will be understanding of digital twin architecture for multi-hazard emergency management, real-time data integration using FAIR principle, predictive modeling, and TOGAF enterprise architecture framework. These are the impacts and benefits. We talk of life save, we talk of operational efficiency, we talk of preparedness, we talk of community protection. All these are the other sub titles under it. Then bottom line is that the digital twin transforms emergency management from reactive to proactive, potentially saving thousands of lives and billions in damages. Thank you very much for your attention. Question and answer.
Thank you. I think you apparently solved the part of the project, Maxwell. So, but thank you very much for detailed information on this. Any question? No question? Okay. So there was one question. Thank you, Maxwell.